All right, ready to dive deep into space exploration.
Yeah, I'm excited for this one. A journey through the history of space science.
Should be quite a ride. Our mission today, using all the cool sources we have, is to track how humanity went from just looking up at the stars to, well, actually launching stuff up there.
Right, from simple observations to complex theories and then putting those into practice. It's incredible.
Totally. So let's start way back in time. I mean, way, way back, like Babylonian star charts around 2000 BCE. Seriously, that early on, humans were already making organized maps of the night sky. It's wild. What do you think was the big motivation behind that?
Well, I think it reflects something really deep within us. Humans crave order. We want to make sense of the world around us. The cosmos in this case. This urge probably had a lot to do with, practical stuff at the time too, agriculture, figuring out directions, maybe even early ways to keep track of time.
It's fascinating how those basic observations eventually grew into full-blown scientific models, though.
Absolutely. Take ancient Greece, for instance. We had Aristarchus proposing a heliocentric model. That's the idea that the Earth goes around the sun. It was a pretty revolutionary idea for the time.
Yeah, but then Ptolemy's geocentric model came along, putting the Earth at the center, and that stuck around for ages. It really shows that science doesn't always move in a straight line.
It's definitely not a straight line. But then, boom, the scientific revolution in the 16th and 17th centuries shook things up big time.
Right, like a scientific earthquake.
Exactly. Copernicus brought back that heliocentric idea, and then Kepler's laws of planetary motion came along. Not only did he figure out that planets move in ellipses, not perfect circles, but also that their speed changes along the way.
Ah, so that's where we get the whole planets don't move at a constant speed thing.
Exactly. And Galileo, with his telescope, actually observed things that backed up these ideas, like seeing Jupiter's moons orbiting Jupiter. That was huge. Finally, Newton came in with his law of universal gravitation, explaining the force behind all these celestial movements. So it was this amazing combination of careful observations and solid math that totally reshaped our understanding of the universe.
And this is where things start to get really exciting. The possibility of spaceflight actually starts to take shape. Late 19th, early 20th century, we've got Konstantin Tsiolkovsky working on his rocket equation. Now, I know this is kind of technical, but what was the big deal about it? Why does this equation matter so much?
So, Tsiolkovsky's equation is kind of a foundational idea for rockets. It basically spells out the relationship between a rocket's velocity, the velocity of its exhaust, and its mass ratio, how much of its mass is fuel. And that principle is key to understanding how to reach the crazy speeds needed to break free from Earth's gravity.
Ah, okay, so it's like the mathematical blueprint for how to actually get a rocket moving fast enough to escape Earth.
Yeah, pretty much. And then a few decades later, Robert Goddard launches the very first liquid-fueled rocket in 1926. That was a massive practical step.
It's like, okay, the math checks out, now let's build the darn thing. And then fast forward again to the 1940s, we get the German V-2 rocket. Bit of a complicated history there, given its wartime use.
Yeah, definitely not a happy chapter.
But purely from a technological standpoint, it was the first large-scale rocket, right? So what impact did that have on the future of space exploration?
Oh, the V-2 was a game changer, even with its dark origins. It showed just how powerful large rockets could be. It proved you could actually launch heavy payloads super high and far. And that knowledge was crucial for developing the launch vehicles we use today.
So even though it was a weapon, it helped pave the way for, peaceful space exploration. And speaking of paving the way, that brings us smack dab into the space age. 1957, the USSR launches Sputnik 1, the first ever artificial satellite. Got to imagine that sent shockwaves around the world.
It was like a Sputnik moment, right? I mean, pun intended. But yeah, it was huge. Suddenly, it was clear we could actually put stuff into orbit around Earth. It was a whole new era.
It must have felt like the future had arrived. And the U.S. quickly followed suit, right?
Absolutely. 1958, Explorer 1 launches, and it actually makes the first scientific discovery in space.
Wow, I didn't know that. What did it discover?
The Van Allen radiation belts. These are zones full of energetic particles that get trapped by Earth's magnetic field. A pretty significant finding.
So not only did we get satellites up there, they started sending back important data right away. And then, of course, came the human spaceflight era.
Oh yeah, the big leagues.
1961, Yuri Gagarin becomes the first human to orbit the Earth. And less than a decade later, in 1969, Apollo 11 lands the first humans on the moon. I mean, talk about giant leaps for mankind, right?
It's mind-blowing when you think about it. And, none of it would have been possible without all the scientific and technological groundwork laid in the decades before.
It really shows how each step builds on the one before it. But we didn't stop at the moon, did we?
Not even close. The 70s and 90s were the golden age of deep space probes. Mariner 9 went into orbit around Mars, giving us incredibly detailed images of another planet. Pioneer 10 was the first to cross the asteroid belt, opening up the outer solar system. And then the Voyager missions, exploring the gas giants and beyond.
Voyager, those are the ones that are still out there, right? Still sending back signals from interstellar space.
Yeah, it's insane. They've been going for decades, sent back tons of data about the outer planets. And then in 1990, the Hubble Space Telescope launched. Talk about a game changer. The images it captured revolutionized our understanding of the distant universe.
Hubble images are just iconic, aren't they? Those swirling galaxies and nebulae. And that brings us pretty close to the present day. The Kepler Space Telescope, which operated from 2009 to 2018, discovered thousands of exoplanets. That must have had a huge impact on our understanding of, well, everything.
Kepler was a revelation. It basically told us that planetary systems aren't some rare thing. They're everywhere. All those stars out there, and they've got planets orbiting them. It completely changed our perspective on how planets form and the possibility of other worlds out there.
Yeah, it's like, wow, we're not so special after all. But that's exciting in its own way.
For sure. And now we have the James Webb Space Telescope, which is looking even further back in time, studying the very first galaxies forming. And we've got missions like the Perseverance rover, actively searching for signs of ancient life on Mars. Astrobiology is a huge focus now.
So it's like, not only are we trying to understand the universe, but we're looking for our place in it, maybe even looking for neighbors.
Exactly. Perseverance is a perfect example of that. It's like our ancient ancestors macking the stars, but with ridiculously advanced tools. That same curiosity, that drive to understand, is still pushing us forward.
It's amazing to think about that whole journey, from those early Babylonian stargazers to the Webb telescope and Perseverance on Mars. It's all driven by this relentless human curiosity.
Absolutely. And it's so cool how each era of discovery has built the foundation for the next.
And as we look ahead, things like Mars colonization and even interstellar travel feel a lot less like science fiction than they used to. It makes you wonder, what discoveries are waiting for us out there? And how will they change our understanding of the universe? It's a pretty mind-blowing thought.
Totally mind-blowing. Makes you want to just hop on the next rocket out of here.
Right? Who knows what the future holds?
Makes the beauty of it. It's all still waiting to be discovered.